Okay, so this lecture I think is kind of hard because it goes into these really deep topics, but it's actually like a pretty surface level look at them. So, what I wanted to do to wrap this lecture up was to try to um, clear up a little bit of that, make some connections to your everyday life, and um, yeah, just kind of see what we can do with that. So, radiation is a term that gets used in science, and it's also a term that you probably hear in your everyday life. Most of us hear radiation and we know that it's bad. That said, you also are now familiar with the electromagnetic spectrum and electromagnetic radiation, and you've learned that that's just kind of like light, it's energy, and that you have a relationship between frequency and wavelengths. And when the frequency of something changes, we have different types of electromagnetic radiation. So it's like, okay, well, then what the heck is going on, right? So the main idea is that some forms of radiation on this higher end are the ones that science has really linked to harmful effects. And those are classified as ionizing radiation. So, ionizing radiation, um, my slides got out of order. Oops. Ionizing radiation is really like that's the stuff that's going to have negative health consequences. So, you know that when you go in the sun, you are exposed to UV radiation, and that is why you wear sunscreen. When you go to the doctor to get an x ray or the dentist, they will often put that like huge pad on you to prevent the x rays from penetrating into your body where they don't want it to go. And then gamma rays, like you probably have associated with nuclear waste, and probably what you think of when you think of like radiation in terms of nuclear stuff, because that's usually what it is. Um, so, what's important to understand is that these types of high frequency, high energy radiation, there are a lot of studies that link it to harmful effects. So, what I wanted to then mention though is that this can get confusing when you start to think about, well, light is radiation. My cell phone emits radiation, like microwaves are radiation, and you can start to wonder, like, how do those things affect me? Which is a totally valid question. But we want to really make sure that we are clear on the difference between something having an effect on you and something being so harmful that it's going to have drastic negative adverse health effects. Um, so I linked here, and I'll link in the description as well, a link to the CDC, the Centers for Disease Control, which is all about radiation and implications for health. Um, and I'm bringing this up because it's really important that whenever you're discussing anything, that you're not spreading misinformation and that you're being informed. So a lot of people will kind of wonder and make claims that these other types of radiation um, are having adverse effects on us as well. And so if you, as always in science, like when you're making claims, you really want to make sure your claims are supported by evidence and reasoning. And again, it's possible, like everything in our environment has an effect on us. Um, but that's not the same thing as it always causing DNA damage or always having like a really acute, drastic effect. So, like an example, blue light gets talked about a lot. We know there's a lot of evidence that shows that blue light and exposure to blue light can affect your sleep cycle, which can have other health impacts too, right? But that's not the same thing as being exposed to like gamma radiation. Um, so when we use the word radiation, it can be confusing. And if you feel confused by it, it's like totally makes sense because the way it gets used in science and the way it gets used in everyday life is a little bit different. Um, okay. So go look at the CDC website and do more research if you want to learn more about radiation. The last thing I want to say is that, again, this lecture is like kind of unsatisfying and that it just stays so on the level of phenomenon. So you might have these awesome questions around like, how can a neutron become a proton? What's a neutrino? What's an antineutrino? Why are we talking about particles like alpha particles, beta particles, and then also talking about waves and rays and gamma rays? Like, what is going on? These are great questions, but they're also really deep questions, and the answers to them are super complex, um, and mostly lie in the realm of nuclear physics, which is not something you're very likely to find in a high school class. If it's something you're interested in, it might be worth pursuing as further education, either on your own in informal, like through books and movies, or through formal education, like further college classes and stuff. It's pretty upper level stuff, so you're not going to come across it like even early introductory college physics classes aren't probably going to go into it very much. It's higher level stuff, but really cool. And I just wanted to also mention that the equation that we've like grown up with hearing, E equals mc squared from Einstein, that equation is actually like where you start to get the answers to these questions, because it has to do with the relationship between matter, like small matter moving very fast, and energy, and what's going on with all of that stuff. Which again, like that's where it starts to answer these questions of like, how can a neutron become a proton and stuff like that. So, really great questions, just not quite what we're going to cover in our class. The punchline, the big picture of what you want here is there are different types of radioactive decay. Radioactive decay is the process of an unstable isotope spontaneously falling apart. When it falls apart, you get this radiation of these small things that are moving fast and going places. And oftentimes, in the process of that, if it's alpha decay or beta decay, your atom is going to go through nuclear change and turn into a different element. The last thing, again, sorry, my slides got out of order, is to just bring it back a little bit to radioactive decay, to technology and society. So when we think about it being harmful or beneficial, it's that energy release that occurs via the radioactive decay that is harmful but also can have benefits. So exposure to that ionizing radiation, that higher end stuff from nuclear waste, or naturally occurring radioisotopes can cause cancer and other adverse health effects. But again, it's that ionizing radiation, that high frequency stuff. And it's because that radiation is able to penetrate through your skin, through organs, into cells, and it damages your cells and damages your DNA. But there are benefits to radioactive decay. Radiation is the mechanism behind so many forms of medicinal technology that you can look up. And like as one example, radiation therapy for actually treating some types of cancer it works because it damages cancer cells. So that can be a little confusing because we're saying, oh, well, like radiation causes cancer and it treats it. Like what? The difference has to do with the amount that you're exposed to, and the kind of like pathway where it's targeted. So over here, if it's causing cancer, it's damaging your cells. If it's treating cancer, it's actually damaging the cancer cells to get rid of them.